What up, what up? Today we're talking about piecewise functions. Now, I'm going to keep it 100 with you. I love piecewise functions. You're not gonna love them. Piecewise functions are kind of what they sound like. You take a nice big old graph, like the one you see right there, and you break them into a bunch of pieces. So they're not usually continuous, but they're functions. As you can see here, I mean, this is a function because if you were to use the vertical line test, let's bring back the vertical line test. Hold on, let me draw a vertical line right there. That's terrible, but fine. If I were to draw that vertical line and go boop, 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 now you're going to want to look at that guy right there and say, it looks like it hits the graph 3 times, but it doesn't, because that circle is not filled in, and that circle is not filled in, so it doesn't count. Boop, boop, boop. It is a function. Now, how do you take that mess and make it look like a piecewise function? What does it look like? Well, like I said, not pretty. Well, this is what it looks like. You're going to say f of x equals, in this case, 3 different things. Okay? One of the things, and you've never learned this yet, you've never learned parabolas in Algebra 1 yet, but I'm throwing this in there. F of x is going to equal x squared, but this only happens for everything 2, not 2, smaller than 2. So it's going to be x squared for all values less than 2. What this is saying is I'm going to graph x squared for all the x values smaller than 2. At 2, y is 6, so when x equals 2, y is 6, that's what that dot stands for. And for everything between, what is this, 2, 3, 4, 5, 6, between 2 and 6, we have the equation 10 minus x, and again, that happens for everything in between 2 and 6. So that looks quite messy, and it is. So we've got a lot on our plate. So piece of garbage is probably what you're thinking. Wise, I don't think so. Function, yeah. Fun, yeah. I'm going to graph y equals -2, x plus 1 in absolute value plus 4, and write out the piecewise defined function. By the way, this guy right here is called the piecewise defined function. So if you recall, we got a lot going on here. My vertex is found by comparing this guy to this. So let me rewrite it. Mx minus h plus k. The h and the k are my vertex, so my vertex is going to be the opposite of 1, which is -1. My k is 4. So if I were to graph this, I would put a dot at -1, positive 4. My slope is -2, which means it opens downward with slopes of 2 and -2, so it opens downward. Here's my slope of -2, just drawing a bunch of points right there. Alright, more dots, more dots, more dots. And I have to make that look like that. Easy. Y, and I'm using y, not f of x, because I'm given y. Y equals a big brace looking thing here. I have 2 parts of this equation, and all the action happens at -1. So my first part is I have this line with a slope of positive 2 that's eventually going to go through 6. I have that line right there with the slope of positive 2 and eventually going through 6, and all of that happens from the negative 1 x value and to the left of it. So what I'm going to do is I'm going to say that I didn't need that y equals there. Let me get rid of that y equals because I already wrote out y equals. It just looks sloppy. Bad job by me. Bad job by me. This is even a worse job by me. All right. 2x plus 6 happens for all the values less than negative 1. And in this case, I'm going to throw in the or equal to part. So less than or equal to negative 1. That looks so terrible. So I'm going to make sure that this guy is x is greater than negative 1 because I can't have it be both. I mean, technically I can in this case. All right. So what is that line? Well, it goes through negative 2, has a slope of negative 2, and that's it. So again, what I'm doing is I have two lines glued together. And they are glued together at negative 1. So stuff is happening to the left of negative 1. Stuff is happening to the right of negative 1. And the stuff that's happening to the left of negative 1 is a line defined by a slope of 2 and eventually has a y-intercept of 6. And so that line would be 2x plus 6. And that's happening to the left of negative 1. And I decided in this case to include negative 1. Over here I have stuff happening to the right of negative 1, and that stuff has a slope of negative 2 and has a y-intercept also of negative 2, which is the equation negative 2x minus 2, and it happens to the right of negative 1. Okay? Not easy. And this is coming from a guy who taught calculus to a bunch of college students, and when I went over piecewise functions every single year, I got a lot of, huh? So if you're looking at this and you're going, huh? And you're in Algebra 1 and not in college, I understand. So, hopefully this clicks a little bit. If not, just play the video on loop and see what happens. Please. Alright, so I'm going to graph this piecewise function. F of x equals negative 2x minus 1 for all the values smaller than 2. X is smaller than 2. Alright, so I'm going to graph this part right here in green. And this is what I'm going to do. I'm going to draw the entire line and get rid of what I don't need. Negative 2x minus 1 means I start at negative 1. Slope of negative 2 has me going up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Draw your line. However, I only care about the x values 2, including 2 and smaller. So there's my 2 right there. I'm going to erase everything to the right of it, and I'm going to bring back that dot right there. Why am I putting a dot there? Because I'm including 2. Okay? The other equation, I'm going to draw in its entirety. Okay, start at 4. Negative x is my slope, positive 4, so bump, 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 bump. Draw my entire line. What do I care about? I only care about the stuff to the right of 2 and not including 2. So I'm going to get rid of the stuff I don't need, including the 2, So I can put a nice non-filled circle right there. What this guy is saying is I'm going to graph this equation but only care about this stuff less than or equal to 2. So this green equation looks like that, and I don't care about any of the stuff to the right of 2. What this guy is saying is you're going to graph negative x plus 4 but only care about the stuff greater than 2. So even though I drew that whole red line, I erased all of that stuff. This is a function because it passes the vertical line test. And this is a piecewise function. Okay. Let's do it again. Again, not fun. I think it's fun. All right, I'm going to graph, this is actually a lot friendlier. I'm going to graph negative x and only care about the stuff that's happening. Well, let's just graph negative x. Negative x is the opposite of the parent function, which looks like this. Oh, no, I missed it. I thought I can get away without doing dots, but I have to do dots. I have to do dots. I have to do dots. I have to do it. I just have to. And a lot of you are like, no, stop doing that because we only care about blah, blah, blah. Well, I'm ignoring you. You hear? I don't care if it looks sloppy at the end there because I don't need half of that. I only care, though, about the stuff to the left of negative 2 and including it. So there's negative 2 right there. I only care about the stuff to the left of it, which means you're gone. There you go. 2, which actually is right there, but I'm not going to include 2, and it's a horizontal line. Now, again, the green line only matters for the stuff greater than negative 2. So I didn't bother writing that way and then erasing it. I saved myself a little bit of time. But isn't that a neat looking piecewise function? That is considered continuous because they're connected. The previous one, that one is discontinuous because they're not connected. However, it's a function, and so is that. Otherwise, it wouldn't be a piecewise function. There would be no fun in piecewise non-functions. Gross. It's the last one we're going to do, though. 3 chunks to this. Now, this is approaching like Algebra 2 pre-calc territory, but, you know, I like having a good time. All right. Negative 2x minus 3, let's graph the whole thing. Minus 3 will make you green. Negative 2 is my slope, so boom, 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 boom. Before I go too far, I only care about the stuff to the left of negative 2. So tell you what, if I only care about the stuff to the left of negative 2, but also including negative 2, then there's my big dot at negative 2, and I'm going to go right there. Okay? Okay. You do that in red. That is negative x plus 4, but I only care about the stuff in between negative 2 and positive 3. So plus 4, negative x, so that's up 1, left 1, up 1, left 1. Now normally I'd put a dot there, but I'm going to not fill it in because we're not including negative 2. Okay? So I'm done going that way. I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, and I include 3 because they told me to include 3. Let's get rid of these 2 dots that are just floating around. All right. Just like in the previous problem, when we have just a regular old number, it's a horizontal horizontal line going through that number, and I only care about that stuff happening after 3, so it's going to be at -5, but after 3, and it is horizontal. If I were to take a perfectly vertical line, like that one, and do a vertical line test, it passes with flying colors. 3 colors. Oh, unless you're colorblind, then it's just like 1. I'd like to formally apologize to all of my colorblind viewers, which I doubt there are any because no one watches these. Thanks for watching, none of you. Bye!